Good morning, sir. This is Geeta from CSCA section. The topic that I got for presentation is recurrence relation on constant solution. Let's get into the presentation, sir. So in this complete presentation, we're going to basically speak about the solution for the given question and the conclusion of the question. Let's get into the question first. So the question is, determine the constants b and c to solve an if a naught is equals to 0, a1 is equals to 1, a2 is equals to 4, a3 is equals to 37 and satisfy the recurrence relation an plus 2, ban plus 1, can is equals to 0. Again, n is greater than or equals to 0. Okay. So the solution is first, to determine the constants b and c for the recurrence relation, an plus 2 plus ban plus 1 plus can is equals to 0 with the initial conditions that were given to us. So the initial conditions is a naught is equals to 0, a1 is equals to 1 and a2 is equals to 4, a3 is equals to 37. We can follow some particular steps for that. Let's see the steps one by one now. So the steps for this is write the recurrence relation for specific values of n. First step, we'll write the recurrence relation for the given specific values of n. First, I will take n is equals to 0. That is, if I take n is equals to 0, I shown a recurrence relation in the previous slide. So if I put n is equals to 0 in that particular recurrence relation, then I'll get a2 plus ba plus 1 plus cn naught is equals to 0. Now again, upon substituting a2 is equals to 4, a1 is equals to 1 and a naught equals to 0 in the relation that we got after the substitution of n is equals to 0, then what I'll get is 4 in the place of a2 I'm writing 4, in the place of b I'm writing 1, so b into 1, in the place of c a naught I'm writing 0, so c into 0, which basically derives me a value of b is equals to minus 4. Now I'm going to substitute n is equals to 1. Now, when I substitute n is equals to 1, the previous reconciliation turns as a3 plus ba2 plus ca1 is equals to 0. Now, I'm not again remember that I'm substituting n is equals to 1 from for the previous slide reconciliation that I shown, but not the recurrence relation in the n is equals to 0. Okay, so upon substituting a3 is equals to 37, a2 is equals to 4, a1 is equals to 1. 37 plus b of what did I say? ba2. So in the place of a2 I am substituting 4. So that is b into 4 plus a1 is equals to 1. So in the place of a1 I am putting 1. So that is c into 1 is equals to 0, which gives me an equation of 4b plus c is equals to minus 37. Right. Now upon seeing this, we can basically say if I substitute the value of b in this particular equation, then I can automatically get the value of c. Right. Let's see that. Now, since b is equals to minus 4 from the first equation, substitute this value into the second equation. That is 4 into minus 4 plus c is equals to minus 37. So upon all solving process, c is equals to minus 21. So the constants that we have is b is equals to minus 4, c is equals to minus 21 after the substitution of all of this. Right. So we got the constants. Next. Now we will have to find the general solution of an. Now the recurrence relation that we have is an plus 2, and so this is the basically the recurrence relation that we've been substituting. An is equals to 0, n is equals to 1. So this is the equation or that we are basically substituting on. Right. Now if I have to write the characteristic equation of this recurrence relation, that could be x square minus 4x plus 21. Now if I have to solve this a quadratic equation, this is a quadratic equation because it has a degree of 2, highest degree is 2, so it's a quadratic equation. If I have to solve this quadratic equation, normally I cannot do. So I'm going to use a formula x is equals to minus b plus or minus square root of b square minus 4ac by 2a. So upon substituting all of that values into the given formula, that will turn into 4 plus or minus 16 plus 84 by 2 is equals to 4 plus or minus 10 by 2. Upon solving that again, I will get my roots as x is equals to 7 and x is equals to 3. Next. Now I have to write the general solution. So general solution for the recurrence relation with the roots x is equals to 7 and x is equals to minus 3 is an is equals to a into 7 power n plus b into minus 3 whole power n. Right. So this is the general solution that we know now. Now we have to determine the constants a and b using the initial conditions that we had. That is, if using a naught is equals to 0, that I'll substitute a naught is equals to a. So there before we had something, no? So in that if I write a naught is equals to a into 7 power 0 plus b into, basically we're just writing wherever we have a naught, that we are substituting with 0. Long story short, that will turn into a plus b is equals to 0. That will give me b is equals to minus a. In the case if I substitute a1 is equals to 1, then it will give me an equation of 7a minus b. So substitute b is equals to a, then I'll get a value of a and b. So next. The final solution that we have after substituting a 1 by 10 and b minus 1 by 10, we will get an answer of an is equals to 1 by 10 into 7 power n plus minus 1 into n plus 1 into 3 power n. So this is the final solution of a power an in the terms of n. And the answer of the complete question that we got is an is equals to 1 by 10 7 power n plus minus 1 whole power n plus 1 dot 3 power n. So this is the solution for an in the terms of n. So that brings to the end of the presentation. Thank you very much, sir, for giving me this question. I learned a lot while solving the question. Thank you very much, sir.